This graph actually has something to do with 2 by 2 matrices, and I discovered this morning. It's really cool. So for like reasons, I was trying to understand this equation here, what matrices would square to this 2 by 2 identity matrix. And when you write down all the equations, I mean, you get a bunch of them, but there's 4 variables, and we can't visualize 4-dimensional space. By the way, this is something called algebraic geometry, where we think about the geometry of equations. It's really close to my own research area, so I love this stuff. But if you look at the equations a little bit more closely, the middle two actually factor. And so if you factor them, there's that common factor of a plus d. And if you think about a couple different cases, well, it's either 0 or it isn't. Now, in the case that a plus d is 0, that means a and d are opposites. And so everything boils down to just 3 variables, and we can graph the solution. Every matrix that's going to square to the identity has to be of this form with this equation true. And that's exactly what's going on here. All of the infinitely many points on this red surface correspond to 2 by 2 matrices that square to the identity. But what about those 2 special points? What's going on with those? Well, remember there was another case. If a plus d is not 0, then we can actually divide these equations by it and conclude that b and c have to be 0. In this case, all of our solutions are diagonal matrices where the entries on the diagonal have to be plus or minus 1. So rather than getting infinitely many solutions, we only got 4. But notice that those 2 middle solutions are actually in both cases because a plus d just happens to be 0. Those 2 matrices occur in both cases, and I plotted those points on the surface. So those 2 points are those special diagonal matrices. I just think this is so cool.